All right. Hello, good morning. So I felt like I had lost my identity a little bit going down the path of breaking up with React and looking at Vue. Mm, but we're back now. Yeah, by the way, this is the PR for Vue that kind of tries to improve some things. We'll see what we do about that. Maybe find time to create like an RFC and just link to the PR, and then for inspiration, I don't really have time to look more into it. But what's really cool is that we were working on this Bubble plugin to do automatic observation, inspired by Preact, and it's working. Like it's the same old. Like Bubble is running in a like a node environment, and it's just the way it like resolves the plugins. It's just a fucking like it's not Bubble's problem. It's the ecosystem. So I had to freaking create. Look at this. I had to create a script called convert CGS, or it should be convert to CGS, whatever, where I actually build the project, because the TypeScript compiler doesn't support changing extensions. But at some point inside, based on your package JSON, and I don't understand this stuff. I hope this gets fixed very soon, because this is a complete mess. And the point is, I have to convert JS files to CGS, but also inside the JavaScript files, I have to change the requires to CJS. It's crazy, but it's working. It's working. So now, let's see. Yeah, we have the example here. So here, just by the mere fact that I'm using the store, it observes. So you don't actually have to do any manual observation anywhere. You just create stores and you consume stores, and then it will just work. If you use MobX, which is mutation based, you might be in a situation where you pass like an object as a prop to a component, for example. And in that case, you will need to manually add the observer, because we have no idea. Like this is what's unique about Impact, is because all the reactive primitives are exposed through a store. So we know where we need to add observation. It's by the usage of the stores, right? While if you just use MobX or just use Preact or whatever, it's much more difficult to understand where observation should happen. So this is actually quite simple, and the only thing it really does is that it, but only on your project files, it would basically just look at the function, finds the functions, and if there's a function there, look for a function call of that starts with use and ends with store, uppercase S. And if you have such a function call, we assume it's a component and you're using a store, wrap the parent function in an observer, and off we go. That's how simple it is. So if you don't have to use the Bubble plugin, because you can add these observers manually. But if you use it, you have to follow the convention of the naming of the hook, which is like how you should name it anyways. So like you could argue here it's like use groceries or something, but yeah, then you can't use the plugin basically. What I did want to explore though is let's close all this stuff. Close all is don't save. And yeah, so what you do, like each of the packages now, let me fire up the docs dev. Docs dev. Oh, what happened here? Am I using... Oh, supposed to look like that. Have I zoomed it in like crazy or something? Wait, what happened? It feels weird. There we go. Next state stores. Oh, it should be nested. Where's the docs? Where's the docs? Index. Oops. Oh, suddenly it's super laggy here. What's happening? Activity monitor. What are you spending all your resources on? Code helper. That's interesting. Let's force quit the code helper. Okay, I'm gonna quit VS Code and then what the hell is going on here? Let's try. Okay, code. Oh, it's docsdev, I think. Yarn docsdev. There we go. Let's see again. So this would be nested state stores. Instead of leaving context and going global, take advantage of nested stores and handle state dependencies like a champ. I thought I would be more like delightful state management. Yeah, be a bit more like silly. I don't care. Because it's really, if you're curious, it's this stuff that's important, right? Yeah, so on the front page now, you have automatic observation. It's a bubble plugin, and all you do is you use your package and you just add transform, and then it will do automatic observation. But I wanted to look at how Vite SVC plugins, like how do you add SVC plugins? How to add SVC plugin? Can you do that? Press the bonuses during development. Yeah, I wonder about this. Like, how would you actually do that? I wonder how it works. Because shouldn't this be like Rust? SVC core. Oh, can you write it? Wait a minute. Name, apply, serve, and oh. What is this? Transform with options. Code. Oh, I have no idea how this stuff works. Like, where's the actual transform? JSX automatic apply. Name Vite. Okay, so I guess this is like the I would imagine this is like the REST code or something, like it's a reference to it. Or something? No. Where's the REST code? Like, I guess you have to write REST to... Oh my god, I'm a little bit dizzy. Scripts. Yeah, no idea how this works. Huh. SWC plugins. Implementing a plugin. Yeah, but how do you like implementing, testing your transform? Publishing. Okay. Creating an npm package. Yeah. But main your plugin name. So you can release REST SVC plugins on npm. How do you actually use the plugins? Yeah, I don't quite understand how this works. SVC core. Like, where do you actually add the plugins? Options? Plugin? Yeah, this doesn't make any sense to me. How do you like... So this is to transpile, but how do you transpile with plugins? I guess, yeah, it did say plugins. Select a runtime. Interesting. Select a version. And then how do you add it? Can I click it or something? This is so very weird. There we go. Oh, so there's an svcrc file. Just like Babel. And then experimental? Why is it experimental? Yeah, maybe we should look at this later. No idea how that stuff works. But we need a Babel plugin anyways to build for production. So, yeah. So what are we gonna do? We are gonna... Oh my god, I'm really dizzy. Oh my god. Oh, that sucks. and see if it wears off. So we have context, we're bashing on context, blah, blah, blah. And then we say, when the React context does not work for us, we have a tendency to replace it with global state management. Doing so definitely solves friction, but we also leave something behind. With Impact, we rather make the React context compatible with the performant and accessible reactive primitives we use for global state management. So we're going to update a little bit here that we implements a reactive context. Since these reactive contexts are designed for state management, we just call them stores. Stores. The store is expressed as a simple function returning the public interface of the store. It is the same mental model as a hook. But this function only runs once when it is when its provider mounts. It's kind of wrong to say mounts. When the related component tree renders. Yeah, that's better. That's more correct. So that's true. Impact supports any reactive primitive. The reactive context is just a mechanism to bridge the world of reconciliation and your reactive primitives of choice. To get going quickly, Impact provides packages. This is not really to get going quickly. This is to get going. Impact provides packages. Yeah, I think it's enough to just state that. So the API has changed. So what we're going to do here now, we're just going to say create store. And now it's not use app store. What we're doing is we're saying const app store provider, use app store, and then we export both of them. Use app store. It would be nice if you could do this, but you can't. So this is the change. And because previously you would just export like use app store. You know what? Maybe we could do the same here. So you would export const use app store. And then use app store dot provide, or provider, I mean. Yeah, we should do that because it's such a boilerplate thing that the structuring operation, it's completely unnecessary. So what we're gonna do instead, we're gonna follow that idea of, let's see. So we're gonna let's see. So we're gonna say use store.provider equals store provider, and then we're just gonna return use store. As simple as that. Yeah, later. Impact React store your build. Yeah, so now is it here that we have it? I have to build Mobex as well, I think. There we go. So we have use store, and what we're gonna do now we're gonna say usestore.provider. So we're saying that this component, the app component, is the provider of usestore. That's what we're trying to express here. We had a little discussion on making sure that it doesn't express that it's only providing it to. So if it was usestore.provide, it would seem like we're providing the usestore to this component, right? But now we're saying that this, just like memo or observer, we're saying provider, that this component app becomes a provider of usestore. Hopefully that makes sense. Cool. Yeah, so that's it. So let's update the documentation for that. Create store. I guess that's all we need to do here. Create store. Legend. Okay, nice. The hook return from return from creator has a provider property to provide the context through a component to any of its nested children. To a component and any of its nested children as well. Yes. So here we're gonna rather do it. So this is what I was like upset about. That you kind of have this artificial thing. But again, here we actually do want to export default is App Store provider. So we would default is the name of it. So we can say, there we go. If you are using the Babel plugin, any components consuming a store will automatically observe changes to that store and memo itself for optimal reconciliation. So configure store. So this comes from the store package. Yeah, and this is still true. Create store. Oops. Has a .provide property to provide the store. To provide the store to a component and any of its nested children as well. This is beautiful. This is truly beautiful, and that you don't have to implement all these observers. It's amazing. If you're using the Babel plugin, any components, we should link that. If you're using the Babel, can I Babel plugin would be index. Oh, look at this automatic observation. Any components consuming a store will automatically observe changes to that store and memo itself for optimal reconciliation. Because that's the whole point, right? Even this counter, if it's using the App Store, it's observing. It doesn't need to reconcile. So it won't ever reconcile because it doesn't take any props. And that's exactly how you want it to work. It should only reconcile if it takes props, and those props change. Like, you can argue about unnecessary, even if it like is less performant in like overall, like maybe most of the time it is more performant. It depends on how much it needs to reconcile here, right? But the point is that it's expected behavior. Okay, reactive context and nested state management. As Impact builds on the existing React context, you will be able to instantiate reactive state management related to specific pages, features, or even for each item in a list. The store can receive props from React, just like normal React context providers. The props are received as an object where each prop returns a reactive primitive representing the value of that prop. This is because React can update the props through reconciliation. You can use the props, you know what? I don't think we actually remove the children now. We don't need this children ref anymore, actually. We're actually gonna skip children, which we already do. And this is just gonna be observable props. Yeah. The store can receive props from React, just like normal React context providers. The props are received as an object where each prop returns a reactive primitive representing the value of that prop. This is because React can update the props through reconciliation. You can use the props with observing primitives like computed, effect, etc., and also expose them from the reactive from the store itself to be used in nested components or stores. Create store can be used in both components and other stores. So what's interesting here, create store, use global store. Yes, all of this is fine. Create store, yeah, this is the same. Let's see. I'm not sure why I'm showing cleanup here. Oh yeah, because we have cleanup. Yeah, so maybe this is a little bit early to show cleanup. Let's go through the examples first. Create store. I don't think this one. Oh, yeah, sorry, I forgot. So, cleanup. Let's see. So this actually needs to be cleanup as well, because now the effect isn't using cleanup. It's not global anymore. It's very interesting, like this whole manual cleanup of effects, side effects. Like it's like in other languages where you don't have a garbage collector cleaning up memory for you. It's the same thing, right? You have to manage your memory, and you can very easily get into like memory leaks if you don't like have a mind. And then you have languages that helps you deal with this. So there's still no garbage collector, but things like Rust has a very rigid paradigm for managing memory. Mm, it's kind of the same for side effects. Like, you're doing something you want to clean up, but unlike memory, well, I guess it's like it's the same as memory in the sense that you want to clean it up when it's not referenced anymore in your runtime or in your code execution or however you express it. And the problem there is that, at least in JavaScript, you don't know. The only time you know if something cannot be referenced anymore is when the garbage collector runs. So you have to like, and that's not like, like you really want this effect to unsubscribe itself or clean up when the related component unmounts or is not part of the component tree anymore. That's when you want it to run. And you can't like automate that unless you were able to create a link between this effect and this App Store instance, right? So if the App Store instance can't be referenced anymore because the component tree has been disposed of, or it's like not referenced anymore by React, that will kind of create a chain reaction where it will go and clean up the effect as well. But it would need to happen immediately on dereferencing, right? Or you could have an effect running beyond the lifetime of the component, which is not what you want. And there's really no good way to really do this. And it's not about impact. This is generally in JavaScript. And this is the same in object-oriented as well, right? Like if you look in the VS Code code base, there's so much disposing going on. It's insane. And they have to like have a good mind for this, like, or intuition about like, okay, I implement all this. I have to make sure that I clean it up. All classes has a dispose method with their internal disposers, and it's like, I remember talking to a colleague about this. It would be so nice to have a language that where you would be able to state that when this effect, like when the disposer is dereferenced, it will clean itself up. It will kind of call itself. That would be really nice. So then you know that if this instance of an app store is dereferenced, so will all its related effects be. That would be amazing. And that's what I was playing around with on the stream. Like, isn't there a way to know when something gets dereferenced in JavaScript? Well, no, there isn't. But how amazing wouldn't it be that you could create these side effects and knows when they're dereferenced and they could just clean themselves up? Then you wouldn't need a cleanup. It would just work. I wonder if any language has that. Let's ask ChatGPT. Does any language have side effects that cleans themselves up when they are dereferenced? Dereferenced? I think you can do something similar, like yeah, finalizers, content ownership and borrowing. Yeah, like one thing you can do in JavaScript is that, so typically a side effect is a subscription, right? So what you can do is you can create a side effect that stops executing when there aren't any subscribers. So for example, oh, we're getting out of this. So what you could do, I think, is that with this effect, you would how should we put it? So this cleanup is putting the function return here. Sorry, the function we pass in here is bound to the scope of this instance, right? It's referenced by this instance of App Store. And so is the return function. But let's just talk about this function. This is referenced by App Store. So what you can do inside the effect is rather put that function into a weak set. So when the App Store goes out of scope, or is dereferenced, so will this this callback be. So internally in the effect, it doesn't have any subscribers anymore. And it should also be dereferenced. You know, I want to play with that because that means that inside, if you use Impact React signals, we can tell you that you don't need to use cleanup. Well, that's not true. That's certainly, well, it should be true. No, it's not true. Well, it's true. It is true. Like, the point is that the effect will still be there, but it won't run anymore. That's the point, because it doesn't have any subscribers. Yeah, I want to try this. You know what? Let's go and create a... Oh, we're completely going to something else here. But I'm very curious about this because I also want to fix the derived inside Impact Signals because that also requires a subscription. And I want you to be able to create deriveds anywhere. Oh, interesting. What should we do? Should we just do well, we can use a React thing. Let's use a dev box. Get away from me. So we're gonna create like an effect, and maybe we can even use it in let's even use it inside but how would, yeah, let's, no, but yeah, I guess it's quite limited. Yeah, because it's different, right? Okay, so I still think we should explore this, but there's a difference. So if you have like an interval running, right? You start an interval, and then when the App Store gets dereferenced, you want to clean up that interval. Like you have a subscription, you want to subscribe to the dereferencing because you want to execute something before it's completely dereferenced. That's not possible. But what you can do is that you can stop execution of subscriptions based on dereferencing. So basically what it means is that you don't need to use cleanup on effect or derived because those are subscription based, right? But if you create an interval and you want to clear that interval, you would still need to use cleanup. So let's see here. How would we implement this? So we want to create like an effect, and that takes a callback of whatever. And what's gonna happen here is, what are we gonna do? So we're gonna have a counter effect, or let's call it counter actually. So you pass it a counter. It's gonna start a counter. Yeah, this is gonna be interesting. So let count 0. We're gonna start an interval. Interval equals set interval, and every second it's gonna increase the count, and then it's gonna pass it to the callback. So let's say count number. And then what we're gonna have is we're gonna have well, I guess we just need a subscribers. It's a little bit weird because we're just calling, we only have a single subscriber, but the closest thing we get to something weak related to values is a weak set. So we can immediately set CB here. And then instead of doing this, we're going to say if subscriber size, I don't think you actually have, oh, don't you have a for each? I thought you had a for each. Okay, then we need a weak map. Can't you iterate weak set? True weak reference. Wait, you can iterate weak map, right? I thought you could. Wait a minute. What am I been thinking about? Event listeners with a weak map. I've seen this. When weak map can help prevent memory by automatically removing entrance. Yeah. So this is the thing I found. Can be garbage collected. Oh, wait a minute. So we're returning. Okay, so we're creating a key. Wait a minute. I don't understand how this works. It's such a mind-bending thing. I have no intuition on like referencing and dereferencing. I just can kind of understand how it works, but it gets very mind-bending to me. So add, remove, fire. Event system add microwave. Okay, so we're adding the thing that can go out of scope or can be dereferenced, and then we add, and then we simulate an event. Target listener. Yeah, so we're using, so in this case, we would be using the store to add the actual effect. Okay, so I guess that's kind of the problem here. But how would you then blah 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 listeners event? New set. Yeah, it's just adding the listeners. That's fine. But then how do you have the target. And then if no listeners. But how does this work? Because if you fire with target, you still have a reference to target. So it can't be dereferenced. When an event target is garbage collected, all the listeners will be detached. Okay, so it just means, so the fire code is like the fire code is part of the target, really. But you might have external listeners added to this is so I guess the point here is that if the thing it's so mind-bending, if this microwave is in a store and it fires events, and that store is gone, then the microwave is gone, then these listeners will just be gone. So what does that mean? So it really means that I have to so basically when you run an effect, it's not enough to just have the callback. Wait, effect. How do we think about this? So this effect is an actual effect inside Impact, and it gets this callback. But what I don't understand is like this fire target event. Okay, this is the thing that I can't wrap my head around, because this is about binding listeners to a target, to an object that can be dereferenced. But here I'm thinking about the listener as the object that can be dereferenced. That's the thing that confuses me. So I kind of want the value to be dereferential, weak reference. These weak references, yeah, but I'm gonna assume it as weak refs in a work in progress. Yeah. Stage 3. Yeah. Yeah, so the finalization is to kind of run code, as I mentioned. Like it will be a cleanup based on when it's garbage collected, which doesn't work for us, but can work in many situations. And I know this is being used for like observation and stuff. Yeah, but I know I'm doing something that you can't do, but I don't understand why I can't do it. I really need to understand this, because I have this reference, and the reason this callback lives is because the store lives. So if the store is dereferenced, this is also dereferenced. But because of this effect, I'm keeping this function alive because I'm referencing it inside here. So I guess I will, okay, but let's, just for fun, let's do target, any, and then we're gonna use a weak map, and we're gonna say, I think we do it like this, target CB. But what I don't understand here is that I'm still gonna have a reference to target here. That's what I don't understand. So I'm gonna keep target alive here because I'm gonna like reference it down here. But if I were to call this effect like from outside from the target, that's why it works for event listeners. Because the event listener implementation is about, for example, a store has an event system, and that store can trigger events. That's the point. And then any outside thing, like a component or whatever, can subscribe to events from that store. But when that store goes out, is dereferenced, there's nothing more. Yeah, that's the thing. Like, that's the thing about this implementation is that, this implementation is that the target isn't referenced anywhere here. The only time it's referenced is when it's like added to the weak map as the key. But then it goes out of scope here. And then it comes back in here, right? But I'm talking about, yeah, so I guess what I wanted to do is like weak ref or whatever that thing is going to be called. And then it's going to be, is it there or not? Kind of thing. But it seems to be based on garbage collection, not dereferencing. But I guess that's kind of the same thing in JavaScript. You don't have true dereferencing in JavaScript. That's what the garbage collector does. It looks at all the objects in memory. Can it still be referenced? And if not, we remove it. It's dereferenced. So that's probably also my mental problem. Yeah. So sorry. So the point is that if you want so what we could have done here to kind of make effects and derived just work is that you would pass in a reference to that effect. So that could have been, I don't know, whatever. It could be anything here. It could be props. It could be cleanup. That wouldn't matter. Just bind it, that effect, to that object. But then it would run beyond the lifetime of this store, because it's only when the garbage collector runs that it is actually gonna remove. Well, that it doesn't make any sense to do that. It makes sense for an event system that's in the store. How? I just have a feeling there's some way we can fix this. It's just a bit too mind-bending for me. So what if, okay, so what if the App Store had an internal implementation of this event system using the week map? And when you run an effect, we can go and get the current store reference and use that to subscribe to the actual effect. So when you run effect, it will check, am I running in, but then it's the same, right? Then it's like you can't run derived. So one thing is effect, because you want to run that with the store. But then you have a derived, and the derived has to be bound to something else, because the derived might be called dynamically. Maybe you have a method that creates like an object that has a derived, and then that derived needs to be bound to, well, that object it's bound to. Oh. But all of this is based on observation, right? So what if we didn't bind it to the store? We would bind it to the signals that are being observed. So what happens in an effect is that we create this context, and then for every signal that's being accessed, we keep track of it actually in a set, and then we subscribe to those signals that's been tracked. But oh my god, my brain is breaking. But what if But what if, okay, and then when it actually subscribes, it will go through the signals and add itself, like the observer context. That observer context is added to each signal. So if the signals would keep this in a weak map, the context and the callback. Well, we actually just keep the context now, but that doesn't work because it's the signal that fires the thing. Oh fuck, how would you do this? Because you can't iterate it. How would you do that? Because it's the signal that needs to fire the event. But it's the observer context that keeps... fuck. So what if this is part of the actual signal? So the signal has a weak map of observer context, but that doesn't even make sense. Like, it only needs observer context. But who's firing? It's the signal that's firing, and it doesn't have the observer context as a target. It's firing because of it has a change. Like, it seems that this is for a very, very specific use case. Like, it's very general. But what? God damn it. Where was I? Observer context. Oh, I have to draw this. Excali draw. This is actually a really good overview. So we have something called an observer context, and then we have like a signal over here, signal. And what happens here is that when you create an effect, so that will be something that's kind of like around the thing here. Oh. So when you create an effect, so this would be like effect that has an observer context, and when that effect runs, the observer context will be informed about any signals accessed. It's the active observer context, right? When the effect runs. So when a signal is accessed, it looks at what's the active observer context, and it registers itself to the observer context. But that's only like registering it. And when the effect is done running, it will actually subscribe to it. And that's when the observer context will add itself as a reference to the signal. So that when the signal triggers now, there's a change on the signal, it will just go through its observer context and notify them, call notify on the observer context. And when the observer context has an unsubscribe, it will remove itself from the signals. So that the signal, like, it's the observer context that's kind of like can be the reference. So if you would do this inside a component, for example, you would unsubscribe to it, and when it's unsubscribed to it, it detaches itself from everything around it. It detaches itself from whatever it was observing. So the signal doesn't hold on to the observer context in any way. But what we're talking about now is that by the sheer dereferencing of the observer context, we're gonna... Yeah, but maybe this is the thing. Like, this should really be a finalization registry. So that you have a finalization registry on the observer context. But that's the thing, right? Because as long as the observer context lives in the signal and the signal lives, it won't be the reference. So it wouldn't work. So what do we actually want here? Oh, why I'm getting stuck in this? I just want to wrap up impact. But yeah, what I would want to do here is I would want to make this observer context have a weak reference to the signal. Yes, that's what I want. So when the observer context adds itself to the signal, it adds itself as a weak reference, which means that instead of the observer context just adding itself to like, I don't know if it's a set or something, it would be like a weak set, for example. But the problem is that now the signal can't reference the observer context, so it can't notify the observer context anymore. So what it, yeah, so this is just isn't possible. Yeah. And the reason it's not possible is because I want the signal to notify the observer context. So if the signal was subscribing to the observer context with a reference of itself, no, that's the thing. Like, I think that's the problem. Like, we would need a third thing here. It's like the observer context would have to say, yeah. So what if we don't think about it as an event name, but as a signal? So it would pass, you have this event hub, kind of like what's here, event system. And instead of being based on a target and an event, like a string, it will be based on observer context and signal, right? What would happen then? So you would have, what would happen then? So you're saying effect. Okay, so when it runs through and it's done, it will immediately go to the event system and say, add this, and then the signal reference, and this is what's gonna happen. And that's basically run the effect, right? Yeah, but this is the problem, because the thing that's gonna fire this event or what if you flip it? So wait a minute. So what if you say add signal this? Yeah. Okay. So you add signal and the context and then the callback. And inside the event system, in the add here, it would be called signals. Let's see. Let's create I guess just TS TypeScript. So let's just change the terminology here. I think this might work. So this would be signals or signal subscriptions. And then you have add, and this would be signal observer context or observer. I guess that's enough. And then the listener. And then we would say this signal subscriptions get signal. And then the listeners is undefined. And then listeners would rather be a new map, actually. And then listeners add observer and listener. Listeners. Oh, it checks if it's there. Sorry. Listeners has has observer, then we do nothing. has listener, like, because you might have multiple signals in the effect, right? But we only want a single subscription for the signal combined. Yeah, just trust me. If has listener or if not has listener, listeners has, let's call it subscriptions. Okay, let's signal listeners. Yeah, signal listeners. This does signal listeners get. If listeners is undefined, if no listeners, we're gonna say listeners is that. And then let's call this, sorry, so we can do get. Let listeners for event was the name of it, but this is listeners for observer. Oops. If no listeners for observer, we're gonna create a new set, and then listeners, we're gonna add the actual listener, and then oh yeah, because we're not adding, let's see, we're re-adding it here. So what we should rather do is listeners. Yeah, sorry. So this signal listeners add signal listeners. So we need to add the listeners. And then we don't have to do it here. And then we say this dot signal listeners oh, sorry, we already did that. So what we would do is we have a signal and an observer. So we're saying if there aren't any signal listeners on this signal at all, we have to create a map. And this is like, and now we're binding this map to this signal weekly. So if the signal goes out of scope, the listeners, like any observer context, any listener goes, like, is dereferenced. And then we say we're checking if the observer already has a listener, and if it doesn't, the thing is the observer only needs one listener. Yeah, unlike an event, an observer only really needs a single listener. So we can say so if it doesn't have, yeah, so I think it's better to just say if listeners, because like it's the same callback regardless of the signal. That's the point. So if the same signal is, but it will only call it once per signal. But there's a one-to-one relationship here. For every combination of signal and observer, there is a single listener. So like it can't have two listeners on the same signal and observer. Yeah, so I think if listeners, but you might, you know what, we're just going to replace it. So we're going to say listeners add observer and then listener. So we're always going to just override it. And then Well, I guess the point here is that we don't really... Oh, but yeah, here's the problem, right? If we... What the fuck? Maybe the pointer is that it's an event, it's a string. Because the pointer, if we're gonna fire something, we need both the signal and we need the observer context. And that's the whole point. We're trying to decouple them. But I could say target, and that gives us... But that doesn't make any sense, because it's the observer context we want to kind of get out of scope. Yeah, this doesn't make any sense. I thought this might have made sense. Yeah, I don't think that it's... I'm not supposed to think this way. I'm really not supposed to think this way. Because here you would also have... You would have signal and observer, right? But now you have a reference to the observer, so it doesn't make any sense. And if I just say signal, fire signal, that's fine. But now the signal has a reference to itself. No, but maybe that's the point. Like, this is where it's going wrong for me, because now we're saying if the signal is the referenced, stop the scope or stop the observer. Which kind of makes sense, but you might, in a store, you might use an effect that has a reference to a signal that's like in a parent store that never goes out of, that's never dereferenced, and that means that that effect will just keep running. So this is not what we want. We don't want to have a relationship between a signal and an observer. We want to have a relationship between the thing that owns the observer and the observer. So here it will kind of be target. So when like a component would, I don't understand this. So we wouldn't add signal here. We would add like a target, which it would be, for example, component. So let's say a component runs an effect. And instead of subscribing directly to the context, maybe that's the thing. So the effect doesn't subscribe on the observer context. What it does is that effect will take, but that's the thing. Like if this is the thing, then effect would have a signature of target like this. And here you would kind of, what the hell would you reference here? You don't have a reference to the actual component in here. So it doesn't really make any sense. But again, we have like the store. So, okay, again, let's think store here. So what if this is the store? So, yeah, but then you can only create effects when we have a reference to the store, which is only when the store initializes. But if you want to create a derived, it would also need a reference to the store. Yeah. No, I don't think this makes sense. It just, it makes sense for an event system like this, because in a generic event system, you want to you kind of want to say, for this target, I want the following event, or for this target, trigger the event. And the point is that the event is triggered internally in the microwave. Was it in a microwave? Why do I keep saying microwave? Yeah, they had a microwave. So the event is fired from within the microwave, and then something is listening to the microwave. And if the thing that instantiated the microwave is dereferenced, any of the external listeners will stop subscribing. That makes a lot of sense. But for us, we are not... what are we creating? Wait a minute. If we think about an effect as instantiating something, that's the point. We're not really returning anything from the effect, but we really are. We are returning a disposer. So the thing we create calling an effect, we're not saying new microwave. We're saying effect. And instead of returning a microwave, we're returning a disposer. So what if... Yeah, this is the thing. And for a derived, we're not returning a disposer, but we're returning a signal. So what if the target here, you have a target, and that target can be, so we're going to have it generic, but for us, the target would either be a disposer for an effect. That's the thing that's going to go out of, that's going to be the reference, right? So the disposer is dereferenced when the store is dereferenced, because you're not really referencing it anywhere. It's in the scope of the store, but we're not like explicitly putting it into a variable, but it's kind of there. Yeah, so let's look at this again. So this target would in this case be the disposer of the effect. And then we have the observer tied to that disposer. But the thing that's firing this is not coming from... Well, it is coming from inside the... It is coming from inside the effect, in a sense. Well, what the fuck? How would you fucking think about this? Oh my god. So how would we use this? We would add the disposer. And the event is kind of like the... That's the thing. It's like... No, that won't work. Because what is this? Okay, so... So here we have microwave, new microwave, right? And internally in, so class microwave, internally in this constructor or whatever, yeah, let's say constructor, inside this microwave, there's like a, yeah, let's start fucking let interval thing. Interval set interval equals set interval. So it's going to count. Let's call it counter. counter. And every second it's gonna say system events fire this, and then count, and then yeah, and we could have like an argument for a value here, but let's not do that. Let's call it ticker. System events fire this tick. But this doesn't, I guess. Oh, okay. Maybe that's the thing. It's like, so even this is where it kind of breaks down, I think. Because even like this interval would still be running, right? You can't clean up the interval, and that's kind of the point of these weak maps, is that you can like have weak links to values, but you can't run anything when something goes out of scope or is the reference. So when the ticker is the reference, the interval, like it can't be, because you have a set interval that has a reference to this. Yeah, I don't like, I can't I can't put all of this in. I don't. God damn it. I can't articulate why this wouldn't, like, where it breaks down. Like, why is this? So the point, okay, let's just write the code for this. So it's not a ticker, it's a thingy, right? And in this thingy, you can do something, right? And then it's gonna fire did something. And then you have this thingy. Maybe it's inside a store. Function store. You create this thingy. You return like an interface, or whatever. Maybe you just return the thingy. And then maybe even here you have subscribe, and you have the callback, and you say system events, add this, did something, callback, right? And now something on the outside that has access to this MV is going to subscribe to it. But then this store is going to go, it's going to be the reference. Like, let's imagine you have a child component that is subscribing to MV. And then the store goes out of scope, and the MV, sorry, it's the reference, like it's unmounted, it's the reference, MV is the reference, and now also this subscription is going to make sure that it's the dereferenceable. You know what I mean? Because if we didn't do this, if we would just have like an internal subscription model, like we would have a set of the callbacks or something, this child thing would just subscribe to like the thingy instance would have a reference to the subscription, the subscriber, because of the callback, like the component, for example, that adds the subscription. And then the component would have a link to the thingy still, which means they can't be the reference because they reference each other. But if both of them are out of scope, or is the reference. Like if both of them are like how can you have access to this thing and create a subscription without that other thing also being the reference? I don't understand this. Is this true? So if I subscribe to something, well, we can test this, and we can test it with React. Like, God damn it, this is not what we were supposed to do. I get so tired of myself. So let's imagine we have const something. Class something. And then we do like const something equals use state, use something. And then we pass something down here. And then we're gonna const registry, new finalization registry, registry. Let's do, yeah, we're gonna have an ID on this. Let ID equals 0. ID equals ID plus plus. And then what we're gonna do, we're gonna return something, and then we're gonna return something, but we're also gonna say registry.register something, and then dereferenced something plus something.id plus the reference. Yeah, and let's create function nested. Well, we need a way to unmount the whole thing here. Export default function const mount set mount use state true. Return got that true return mount, and we do app, or we do null, and then I don't know, use effect, set timeout, set mount false. Yeah, and then let's, I think this is strict mode, so timeout. Why is it giving me such a hard time? All the lines, all the yellow lines. Why are you complaining? Ah, wrapper. Okay, and this takes props, something, any, whatever. And then what we're gonna do is return hello world. And then we're gonna have a use effect, which is just gonna subscribe to props something subscribe. And something is gonna have, well, we can say that this is something. Subscribe, and then we get a callback here, and we're gonna store subscribers, this new set, let's just say any, and then this subscribers add CB. Okay, so now we're creating a link between these things. And how did this finalization registry work? JS finalization registry. Yeah, it's just a callback. Where do we do this? Well, I think I can just do console log. Okay, so after 1 second, it's gonna unmount, and then let's not subscribe, and then see if it dereferences everything. Let's see, do we have memory here? Memory, it's in the other thing. How do I open the other thing? Show console drawer. Oh, it already did it. Okay. So, and then we run this. It's dereferencing both of them, right? But what happens if I subscribe? Amount. It's still dereferencing it. Yeah, so that makes me think that because of the nature so that makes me think that because of the nature of this nesting, like, because the only thing that can subscribe to the store is nested, right? So if the store unmounts and is dereferenced, everything nested is also dereferenced, and then it's fine. But how does this... So if I have an effect... So if I have an effect in a store that points to signals in that store, and then the store is unmounted, it can't be referenced anymore, the signals inside that store can't be referenced anymore, and the effect pointing to those signals has a subscription to those signals, but they should all be cleaned up, right? Because nothing can reference any of it anymore. But if an effect has a reference to a parent signal, then that effect will keep running. So it's not really about the subscription itself, it's what you're referencing inside the subscription. But it's kind of weird to me, like if you have access to subscribing to something like the microwave, in what world in what world would that thing be like nullified or dereferenced, and the thing that subscribed to it would not be dereferenced? That's really weird to me. I don't understand that. That doesn't make sense to me. But it's definitely an issue. Like, so for a derived, for example, so if you create a derived that Yeah, it's interesting. It's like in this example, this effect here, this needs to be cleaned up because it's referencing. Well, no, it doesn't, because you're not actually referencing. You're not actually referencing something outside. You're referencing props. You know what? We're just gonna fucking run this, and then we're gonna see what's happening. Yeah, we're gonna do some actual checking here, because I'm not sure if you need this cleanup. Like, you need a cleanup if you actually want to execute a disposal or an unsubscription. But this is about observation. Yeah, this is very interesting. Okay, let's see if we can create an example. Let's run dev-vite instead here. Let's see. Oh, I have to eat something. Let's see, app tsx. So this will be use store now instead. Use store provider. So what are we checking here? What we're gonna check is that so yeah, we're gonna have, yeah, I guess we can test with auto run as well. And what are we gonna check? We're gonna check if the callback is dereferenced. Yeah, does the callback, the function we give to auto run, does that go out of scope when we unmount the store? So let's do well, auto run. Let's add another finalization registry here. Const registry, new finalization registry. Yeah, console log. And what we're gonna do is const callback log hello, and then we're gonna say registry register callback and whatever out of scope, and then we say callback, and I think we can like do, we can even do a props thing. Well, let's do something simple first. So we can just keep this as is, and then we're gonna, let's see, const app, and then we're gonna do the same kind of thing. Oh my god, I'm super hungry. Function wrapper const mount set mount equals use state true, return mount app or null, and then we have a use effect with the const timeout, set timeout, set mount false after 1 second, return disposer, clear timeout, timeout. So in theory, this callback should be dereferenced. So are we running it? No, yarn dev. So this is 5173. Oops. Process is not defined. Oh, doesn't oh, wait a minute. I haven't built anything here, I think. Impact React store yarn build, and then impact React mobx yarn build. Or I have an issue with the transformer. Is it using the transformer? Yeah. Ah, for fuck's sake. Where is it using process? Bubble types. Where is it coming from? It's coming from bubble types. Bubble plugin, Vite, bubble plugin. Process is not defined. It's interesting. I think you can just add process. Yeah, you can just do this, but that's concerning, right? Why does it work like that? Because one thing is in your app, right? That's fine. But what about define? Yeah. What about all the libraries? Yeah, out of scope, right? So what if we pass a prop to this thing? Props. So let's pass count, and this is gonna create like an external kind of signal kind of thing, or not signal but observable. I guess we can just put a number in there. But that's also dereferenced. So we say hello props count. Oh, what the fuck happened here? Oh, did I do something bad? Ooh. Yeah, I've done something bad. Why is this happening? It did go... Oh, yeah. Why is this throwing an error? Object get. That should be fine. I'm just running object get in... This is very interesting because I didn't know about this, but this is actually brilliant. Because of this encapsulation of a store, it's actually perfectly... Well, okay. So if you were to use a parent store and then like... We should test that as well. But I have no idea what happened here. Why the hell do you get... Why is this creating a loop? We're just getting the... We're just getting the observable prop. Oh, sorry. I see what's wrong. It's actually a bug. Dot get. We are pointing to the key we actually just added there. So this should be... Wait a minute. So these are the observable props. Key in props. Where are the actual... Two observable prop? Okay, so yeah, sorry. So these are the actual, these are not the things we're going to pass in. There's something else we're going to pass in. Let's see. We're going to go through the keys, and that this is a different object. But do we need... yeah, we need observable props ref to update it. But do we need store container? No, we only generate the store here, right? Yeah. So yeah, sorry. So we need another store props equals as any. So we need to do this. And then we pass the store props in there like that. My bad. Impact React store build. There we go. Yeah, and we autoscope. Nice. So let's try now to... This is a really nice thing. I didn't realize this. Because of the nested nature of how you're accessing all of this, it will just work. You're safeguarded by the nesting of access. That's actually really, really cool. So cleanup isn't necessary for observation, not for reactions derived, computed, or anything like that. It's only necessary if you explicitly want to clean something up, like if you're manually subscribing to something, you want to stop that subscription. And that should stop when the component unmounts. That's the important part. We could explore, like we could use finalization registry, like, or approach the referencing, those things as well. But that would change the API, I think, and wouldn't make any sense because it would happen on garbage collection. And if you have a subscription to something, you want to like stop that subscription. But let's try. This is very interesting. But why is Mobex saying you have to be careful with reactions? I think it's because of like memory footprint type of thing. But what I think could happen is like, if you have like an API, if you have another store, a parent store, that's not... Let's try that. So let's create cons wrappers. Where the hell? Oh, sorry. Where's the thing we were playing with? Up here. There we go. So what if we have a wrapper store? Use wrapper store. Create store. And what we're doing here is that we're gonna just return some observable count or whatever. And then provider. And what we're gonna do, yeah, I haven't actually tested this. Let's try to use the wrapper store here. And then we access the count. . Store is not a function. How did that happen? How could store not be a function? That's literally... Oh, fuck. I know what's happening. Damn it. It's the transform. I have to have some food. But yeah, two things to fix. Like, the reason is that we're using use wrapper store inside the store. It thinks it's a component. So it adds observer to this, and then it breaks. And there's no difference. God damn it. Well, we can check. Yeah, we have to. Well, the plugin is based on convention. If you're not following the conventions, you're in trouble. So so what we have to check is, God damn it, we have to check if the function has store in it. God damn it. Or we should check that it actually returns JSX. That's what we need to do. And I know Preact is doing that. We should steal that code. It's a function that uses a hook and it returns JSX. That's what we're gonna do. Preact signals, GitHub. They do this in their Bubble plugin. I guess React Transform. Contains JSX. Is component function. Get data. So it uses path dots. Oh, interesting. I think they're just regexping. Where's get data? I think they've abstracted this a little bit. Where's the actual get data? Oh, there we go. Node get data. Huh? Get data. Data namespace. Name? Is this like a special thing? Can you do this? Okay. We're gonna try this. So I just need to eat something. So we're gonna fix the transform, and then we're gonna double check this. And the whole conclusion on this is gonna be that you're safe to use like any effects derived, computed. Just go ahead and use them. Don't be worried about memory leaks on that. Because of the nature of like the hierarchy of stores and components, there's no risk of but why is that? Is that unique? How do you create a memory leak with an event listener? I see it with window, right? Because window never goes out of scope. Yeah, so it's if you add a listener to, that's the thing. Like if you if you would get, yeah, that's the thing, right? Because if I were to use Wrapper Store here and I would add a listener to Wrapper Store, just as I talked about, what if you add an explicit subscription? Then you have to clean up that sucker. Where you could use this global event system to avoid that, right? You could have a reference to props or cleanup or whatever, and you could use that to kind of, but then that had to be used by this other thing as well. It doesn't matter. But the point is, we're not adding subscriptions to any parent references. We're adding subscriptions internally, and then there's an implicit pointer to a parent, but the subscription lives here. So when here is the reference, so is the subscription, I think. Yeah. That's how I think about it. Because I thought you need to like put cleanup on every auto run and everything, but you don't need that. It's only for explicit subscriptions. Anyways, cool. I'll see you later.